Okay, good day. So we will be discussing today all about rational functions. Okay, so first, what is a rational functions? So rational functions is in the form of f of x is equal to p of x over q of x. Okay, so where p of x and q of x are both polynomial functions and q of x is not equal to 0. Okay, so first things first, so that is why rational functions are known to be rational, because it pertains to the ratio of two functions, which is the polynomial p of x and the q of x. Okay, so the most important prerequisite in order for us to identify if a rational functions if a function is rational, both functions, both p of x and q of x, should be a polynomial functions. Okay, so a polynomial functions, and other than that is that q of x, which is the denominator, should not be equal to 0. Okay, because when a function, when a polynomial such as p of x is divided by 0, let's say q of x is equal to 0, the answer will be undefined. Okay, so a polynomial, so let's discuss first or review first what is a polynomial. So a polynomial, it could be a monomial, or meaning one term, a binomial or two term, trinomial or a three term, so on and so forth. Okay, so a polynomial could also contain a constant wherein the degree is 0, meaning to say x is raised to 0. It could be linear when x is raised to 1, or it could be also be quadratic, which is x is raised to 2, or cubic, x is raised to 3, and so on and so forth. So the most we should consider that a polynomial should have this degree, meaning a non-negative integer. Okay, so meaning to say it should be a whole number. It could be also 0. It could be a whole number, for any whole number, for as long that it is non-negative and it is an integer, meaning a fraction. It should not be considered as a part of a polynomial. Okay, so let's have an example. So let us tell whether if these examples are rational functions or not. So again, a rational fraction should contain a p of x and over q of x, meaning this is the ratio of the two expression, p of x and q of x, wherein p and q should be both polynomial and q should not be equal to 0. Okay, so let's try. So for the first item, x squared minus 4x minus 1 over x plus 2. So let's examine the numerator. So the numerator is a polynomial. A polynomial is, which is a trinomial. Because it has three terms: x squared, 4x, negative 4x, and negative 1. There are three terms inside this polynomial, and it is on the second degree because the highest exponent of this function is 2. So all the terms inside this polynomial contains exponent of x's, wherein the exponents are all non-negative and integer. So such as x squared, which is 2. For negative 4x, the exponent of x is 1. And for 1, the exponent of x is 0, right? So that is why we don't need to write x raised to 0, because that is equal to 1. Okay, so this is a trinomial quadratic. and this is a polynomial. So for the numerator, it is a polynomial. However, for us to consider if this is a rational fraction, the denominator, for example, for a p of x over q of x should be also polynomial. Okay, so let's examine the denominator if it is a polynomial. So there are two terms. So if it is a polynomial, it will be a binomial. And the degree of this polynomial will be 1. So it is a linear binomial. Okay, linear polynomial. Okay, so if you examine all the x's inside this binomial, all the exponent of all the x are all non-negative integer. So for x, the exponent is 1. For 2, the exponent is 0, right? So numerator is a polynomial, denominator is a polynomial, meaning to say this one is a rational function. Okay? Next one. 10 over x squared. Okay, let's examine. So this one contains only one term, which is 10. So this will be a monomial, no? Monomial. Okay? And the exponent of all the x's, even though we don't see an x here, we could tell that if it is a variable, let's say an x, this will be 0. So still, even though this is not a positive number, for as long as the exponent is non-negative, this should be considered as a polynomial still. So x squared, this is a monomial, specifically a monomial, and the degree is 2. So the degree is 2, so the exponents are non-negative integer, so we should consider this as also a polynomial. So the 2 exists as a ratio of these two polynomials, so this is a rational function. Okay, next one. Square root of x plus 5 over 2x minus 2. So something unique about this function because we have a radical sign. So first, let's examine the denominator. So I will be coming to the denominator. So we are pretty sure that this is a polynomial, right? So exponent of all x's are all non-negative integer. Okay, so we see an x, which is an exponent of positive 1, and an x here, which is not written, which is the exponent is raised to 0. So however, the numerator is not a polynomial because this whole term and pertaining to this whole x plus 5, the usage of this exponent is, it means that x plus 5 is raised to 1/2. So if x plus 5 is raised to 1/2, the exponent is not an integer. So it is in a fractional form. So it means that this overall functions is not rational function. Okay, hope that is clear. So this is not a rational fraction, so I will need to highlight this one. Okay, so next one, x negative 3 to negative 7 and 4 over 4x plus 3, we could tell easily that this one is polynomial. However, if you see this x raised to negative 3 minus 7, we could see that the exponent of x is negative. Even though the exponent is an integer, exponent is still negative. We could not consider this one as a polynomial. So overall, this will be not rational also. Okay? So this is a not rational function. Lastly, so we have here x squared 1 over x squared minus 9 all over x plus 4. So before we assess each numerator and denominator, I would like to express this one in a simpler form. So this is a complex fraction, so I would like it to be less complex, wherein all terms will be designated on its specific position. So if it is a numerator, I would like to have a single numerator and a single denominator for this complex fraction. So I would like to represent this one. So since x squared is a denominator here, we would like it to drop down to the denominator. So when you express this one in the division operation, this is 1 over x squared minus 9 divided by 1 over so this will be the division part, right? This is the division part, so it means that this is x plus 4. So I would like to represent this one. So this will be 1 over x squared minus 9 multiplied by 1 over x plus 4. Now when we proceed to multiplication, this will be 1 over x squared minus 9 over x plus 4. Okay? So let's examine. So the exponents, okay, so the numerator is a polynomial, so the exponent of x is raised to 0. At the bottom, at the denominator, all the x's, when we extract this one, we will be having 1 over x cubed minus plus 4x squared minus 9x minus 36. So this will be the whole expression. So this one is polynomial. This one is a polynomial also with a degree of 3, and all the all the exponents of all the x's are all non-negative integers. So this one is considered a rational. So this will be a rational expression. Okay? Thank you.